Alright, hello. We're going to go over the reassessment day number 2. I'm going to go ahead and call this the answer key. So, the first standard that was given to us was standard 2C, linear equations in multiple representations. Mr. Hortonberry's race was modeled by the equation y equals 4x. So right away we got to assume we're going to have some racers and we're going to see who's going to win. And we're going to have to graph them. So y equals 4x, let's fill in the table. Y equals 4x means we have to multiply x by 4 to get y. So 4 times 0 is going to be 0. 4 times 2 is going to be 8. 4 times 4, 16. And 6 times 4, 24. I'll check for mistakes. Nothing. These numbers are good. That's Mr. Hortonberry. We can go ahead and graph him now. 0, 0. Right there. 2, 8. Right there. 4, 16. Right there. And then 6, 24 will be off my graph. So that means that this line right here is going to represent Mr. Hortonberry. I'll go ahead and put the letter H for Hortonberry. Okay, next up is Mr. Waster. In the tricycle race, Mr. Waster got a head start of 7 meters and pedaled 3 meters per second. Okay, we know this is y equals mx plus b. 3 meters per second is obviously the slope. It's going to be how fast he's going. So slope is going to be 3 meters per second. And the starting value, so m is slope, b is starting value. That's going to be a starting value of 7 meters. We can go ahead and check what is meters on the graph. 7 meters is going to be x or y. We can see that meters is going to be the y. So it is the starting value, the y-intercept. So y equals 3x plus 7. We're going to go ahead and graph that. So Mr. Waster got a 7-meter head start. And after that, he traveled 3 meters every 1 second. So up 3 meters every 1 second. Up 3 meters every 1 second. Up 3 over 1. And we can go ahead and graph this with the letter W for Waster, Mr. Waster. Okay, next up is Miss Zuckergy. Miss Zuckergy's race is modeled by this completed table. So with that, I just need to go ahead and graph it, but also come up with the equation. So I guess I'll start with graphing Miss Zuckergy's table. So it says 2, 0, 4, 5, 6, 10. Just being very careful to not make any mistakes here. 8, 15. And 10, 20, which will not fit on my graph, but I can put a dot there anyway. So this line right here is going to represent Zuckergy's race. So I'll put the letter Z for Zuckergy. Okay, we need to come up with the equation, so that means we need to know what the slope is and what the starting value is. Again, y equals mx plus b. We know the slope is going up 5 for every 2 seconds. So up 5 meters every 2, up 5 every 2. So we can go ahead and say that the slope is 5 over 2. Remember, slope is change in y over change in x. Change in y over change in x. So it's going up 5 and over 2. We can confirm that with the graph. Up 5 over 2. Up 5 over 2. 5 over 2x plus b. What's my starting value? Where does it cross the y-axis? If I go down 5 and over 2, I'll see that it crosses at -5. So plus -5. I can just go ahead and get rid of the plus sign since it's 5 over 2x minus 5. Please excuse my error. Okay, let's go ahead and confirm that with another way just to make sure that we have our table with the starting value. Our table should be 0 comma something. So if I subtract 2, how much should I subtract going back? Right, it's going up by 5. So I should be going down by 5, meaning the y-intercept or starting value is -5. All right, it says to graph it. We completed that. I'll put a little check mark. Why not? Number 5 says if the race was 16 meters, so 16, not 16 seconds, but 16 meters. I'll put a little finish line. Who got there the fastest? So in first place, we can see that W, Mr. Waster, got there first. In second place, we can see that H got there, Mr. Hortonberry. And in third place, it looks like Miss Zuckergy got there a few seconds late. And that is standard 2C. Let's move on to standard 3C. All right, standard 3C is multiplying using area models. The first one is an area model that's already completed for me. That's great. Something to keep in mind is we need to make sure to remember some things have squareds. And how do we get squared? We get squares when we're multiplying something by itself. For example, 4x times x. Well, x times x is x squared. So something to really keep in mind is we have to be careful not to forget those x squareds. Okay, so next thing I want to point out is there's a difference between area sum and area product. Area sum is just whenever I add up all of the inside area, what will I get? Keep in mind there's going to be like terms sometimes, and I must add them together. So if I add up all of these terms, I will get 4x squared, 32x plus 3x, like 32 apples plus 3 apples. It's going to be 35 apples, like terms. And finally, we're going to get 24. So this is my area sum, the sum of the inside. By the way, what does the word sum mean? Sum typically means add. So it's important to remember that we just added the inside values. Now, to get to the product, I'm going to go ahead and highlight the product as length times width. The word product does mean multiply. And I'd like to also add that this is going to be multiplying the length of this figure by the width of this figure. Do you know that the area of every square or every rectangle is going to be length times width? So we just have to write the area as a product of length times width. How long is this? Right there. It's x plus 8. I'm going to put that in parentheses. And how wide is this? What's the width? 4x plus 3. Remembering to write the x value first, variable first. So something else to keep in mind is how do you remember the difference between the two? Sum is add, product is multiply, but you can also tie the word product to the word what? What are these symbols, right? Product will be tied to the word parentheses. A way to easily remember that there's a difference between sum and product. Okay, next up, let's try the second one. The second one is going to be an area model that's not filled out for us. So we must multiply to get the inside area. 5x times x is 5x squared. 6 times 5x, see where they cross? 6 times 5x is 30x. Negative 6 times negative 4, see where they cross? Is negative 24. And negative 4 times x is negative 4x. Now I'm going to go ahead and carefully add these, remembering that there is going to be some like terms typically on the diagonal. 30 apples and -4 apples, right? 30x and -4x. So I have to add those. Just remember to put the highest power first. So 5x squared, 30 apples minus 4 apples. It's 26 apples. Minus 24. Okay. Now next up is the length and width. This one was actually given to us. We just have to remember that product typically means what? Right? Parentheses. So let's go ahead and put this in parentheses. It doesn't matter the order here. We can do the width first, 5x minus 4, and then do the height or the length. So I'm going to write this as not plus x, or sorry, plus 6 and x. I'm gonna write the letter x first and write x plus 6. This is a perfect answer. 5x minus 4 times x plus 6. And when you actually multiply that, you get the sum. 5x squared plus 26x minus 24. We multiplied to be able to get the sum. All right, that was the correct answer. Let's move on to the next one. This one is more like a puzzle where you're missing certain pieces of it. You got to figure out what multiplies to get the inside value. So -9 times what is -9x, right? Let's just confirm that we have the right answer here. We can go ahead and say that this is x, -9 times x. Now these two we can multiply to get the inside. There, see where they cross. -9 times 3 is -27, and add the y. Not apples, but oranges there. Okay. Next up is we can figure out this outside value. What times 3y is 21xy? That's kind of tough there, but we can figure it out. As 7 times 3 is 21. And then we need to get an x there, so it's going to include an x. Let's confirm. 7x times 3y, 21xy. Yeah, that's going to be the right answer. Lastly, we now have the enough information to figure out what this piece is. 7x times x, see where they cross. That's going to be 7x squared. Very important to remember the square. X times x is x squared. Okay, let's fill out the area as a sum. I'm going to carefully do this so that we don't make any mistakes. All right, I'm going to notice there aren't any real like terms here. We have x squared, xy, we have the apples, we have the oranges. None of these things can we add together, so I'm just going to put them in an order that makes sense. The highest power I can put first. 7x squared plus 21xy. Then alphabetical order. Minus 9x and minus 27y. Now that I figured out the outside values, right? The previous one, it gave us the outside values here too. But this time, we had to figure out the outside values. So now that I have the outside values, I'm just going to multiply in parentheses 7x minus 9 times x plus 3y. And we got it. That's the answer. Finally, we do have a problem where it does involve some algebra tiles. This one's a little different. We know x times x is x squared. Now x times what is x, right? These are all going to be 1s. X times 1 is x, just to confirm. All of these are going to be, of course, the 1 tiles. 1 by 1s. I like to put a little dot at the center, kind of like a die or a dice. And now we have everything we need to figure out the area sum. So area sum is just going to be adding up all the inside values with like terms. A lot of apples here. We have x squared, 1x squared, plus how many apples? How many x's? 7 x's. Remember to count every single one. 4 plus 3, 7. There's 7 x's. And then there's how many 1s? It looks like a 4 by 3. So that's going to be 12 ones. 12 ones. 12. And finally, going to give us the product. How long is the length of this rectangle? Remember, area of a rectangle is equal to length times width. So let's count how long this is. X plus 4 in parentheses. That's how long it is. And what's the width? The width, or the other length, is x plus 3. That's my answer. All right, we're going to go ahead and move on to the last standard that I like to go over for the reassessment day. This one's going to be slopes of parallel and perpendicular lines. Slopes of parallel and perpendicular lines. So let's get right into it. If this one says to circle or highlight the equation that is parallel to the line y equals negative 5x plus 3. Explain in detail how you know those two lines are parallel. I'm going to go ahead and circle the correct answer. There's only one here because we know that parallel means same slope. By now we know it should be slope is the number in front of the x. So we need these two numbers to be the same. And if we take a look at all of these are the only ones that have the same slope of negative 5. So to add more detail, we could say they both have a slope, or m, of negative 5. So in words, parallel means same slope. And just to visually show that, parallel just means that these lines will never cross, meaning they have to have the same slope. Okay, let's move on to number 2. Number 2 asks you to circle or highlight the equation that is perpendicular to the line 2/5 x plus 7. So we need to look at the slope again. The slope here is 2/5. And we need to explain in detail how we know these two lines are perpendicular. So perpendicular means if I have a line that looks like this, the other line actually needs to look like this. Why? What does the word perpendicular mean? Let's check. Let me ask Siri. What does the word perpendicular mean?
As an adjective, perpendicular means at an angle of 90 degrees to a given line, plane, or surface. Do you want to hear the next one?
That's okay. It does have something about slope. It says it has to have a slope that intersects at a 90 degree angle as well. So let's see, 2/5. This was up 2/5, which kind of looks like it, up 2/5. Then what's this slope going to be perpendicular to it? So we know that this one is a positive slope, and to be perpendicular, it has to be negative to be able to cross at this perfect 90 degree angle. Okay, so I'm going to go ahead and circle the right answer. The correct answer should have been negative 5/2 x. So one thing is this one is a positive slope. This one is a negative, but there's more to it. Perpendicular means negative reciprocal slope. So if I said 2/5, then I need to flip it and also make it negative. So any number that I give you, you should be able to flip it and also switch it. I call it flip it and switch it for perpendicular. So in words, perpendicular means slopes are negative reciprocals. Some people also say opposite reciprocals, and I like that as well. Opposite reciprocals. And just as an additional practice problem, I can give you something like this. What if I gave you a slope of -7/8? How do you flip it and switch it, right? So you have to do the reciprocal, which means flip it. But there's no longer a negative sign. You have to switch the sign to positive. Okay, so this slope would be 8/7. And another one, what if I gave you a slope of 2? How do you flip a 2? Well, it has to be written as a fraction. So 2/1. And now that's going to be -1/2. So just some additional practice for perpendicular. This problem right here, number 3, actually is something very similar. It says to write an equation of a line that is perpendicular, 90-degree angle, to 7x plus 2. 7x plus 2 kind of looks like this. A really steep slope. And to be perpendicular to it, it must look something like this. 90-degree angle. So this one has a slope of up 7/1. And to be perpendicular to that, I must go down 1 and over 7. So the slope, I need to change the slope to be a negative reciprocal. 7/1 becomes -1/7. And the y-intercept, it doesn't matter. It could be any number, even 0. What really matters is that we have the slope as opposite or negative reciprocals. So correct answer, -1/7 x plus, you can say -1/7 x plus 9. That's perpendicular. -1/7 x plus 2. That's still perpendicular. Even if the y-intercepts are different, it doesn't matter. They're still perpendicular. Okay, number 4, it says write the equation of a line that is parallel to 4x. Well, what does parallel mean? Parallel means same slope. So we just have to make sure that we keep the slope of 4 the same. Here's the catch. It has to go through the point -1. Interestingly enough, this is a y-intercept. So if I have to say y equals mx plus b, we know that b has to be -1. So I'm going to go ahead and say y equals 4x minus 1. And that is the answer to number 4. That wraps things up. If you have any other questions, please reach out to your teacher. And good luck. Have a great rest of your day.